is 1.66 into 10 power minus 27 kg is equal to E divided by C square. So mass in terms of energy, the mass of the constituent particles is called as mass defect, which is accelerated by a potential of 1 volt. Then where is that missing mass going? It cannot evaporate like that. Hello students, let us continue our discussion on the chapter Nuclei. In my previous session, we have discussed the characteristics or the so-called features of the atomic nucleus. We spoke about the atomic size, where we told the radius of a nucleus is directly proportional to the cube root of its mass number. We spoke about the atomic mass. We told atomic mass is measured in a unit called atomic mass unit. And finally, we discussed about nuclear density. The order of the nucleus was around 10 power 17. Very, very high. Therefore, we concluded that nucleus is in a highly dense state. Continuing my session today, we will understand a few other concepts, basic concepts that are related with the nucleus. The first one is the famous Einstein's mass energy equation. This actually is a separate domain in physics. It is from the theory of relativity, but we simply understand the skeletal of this description. Before Einstein could put forward his mass energy concept, people strongly believed that mass and energy are two different quantities. Mass cannot be expressed in terms of energy, nor energy can be expressed in terms of mass. They thought they are non-interconvertible. But Einstein, from his special theory of relativity, a concept called special theory of relativity, established that mass and energy are interconvertible. Einstein shows mass can be expressed in terms of energy, or energy can be expressed in terms of mass. Therefore, he puts forward a very important relation, E equals mc square, where c is the velocity of light in vacuum. So if you observe here, we are expressing energy in terms of mass. E is equal to mc square, or M is equal to E divided by C square. So mass in terms of energy. So very clearly we understand they are not two separate entities. Through special theory of relativity, I can express mass in terms of energy and energy in terms of mass. Now, we go on to the definition of something called as electron volt, EV. Many a times we have used this definition in the calculation of energy, electron volt. We told it is the kinetic energy acquired by an electron. Electron volt is the kinetic energy which is possessed by an electron, taken up by an electron, which is accelerated by a potential of 1 volt. An electron which is accelerated when a potential of 1 volt is applied, then its kinetic energy is what we call as electron volt. So, a very simple definition here. We say electron volt is nothing but the kinetic energy. Who is acquiring that kinetic energy? It is the electron. On what condition? When it is accelerated by a potential of 1 volt. So, kinetic energy acquired by an electron which is accelerated by a potential of 1 volt. And that is what we call electron volt. Now, this is very important. A very important 2-mark question. A mathematical calculation here where I have to show one atomic mass unit is nearly 932 million electron volts. Yesterday when we spoke about atomic mass, my dear students, I showed one atomic mass unit was 1.66 into 10 power minus 27 kg. Madhudva, in yesterday's class, we clearly showed one atomic mass unit is 1.66 into 10 power minus 27 kg. But now I am proving one atomic mass unit is 932 MeV. How? Now I will consider Einstein's mass energy equation. So, E is mc square. From the special theory of relativity, I am considering Einstein's mass energy equation. I told 1 atomic mass unit is 1.66 into 10 power minus 27 kg. 1 AMU is 1.66 into 10 power minus 27 kg. And velocity of light in vacuum, the exact value 2.9979 into 10 power 8 meter per second. This value na Michelson-Morley experiment ಕಂಡುಹಿಡಿದಿದ್ದಾರೆ. The exact value of velocity of light in vacuum is 2.9979 into 10 power 8 meter per second. So substituting E equals M 1.66 into 10 power minus 27 into C square 2.9979 into 10 power 8 whole square, which gives me the value 14.919 into 10 power minus 11 joules. If you use your calculators, simplify this, energy is 14.919 into 10 power minus 11 joules. But I have to express this in electron volts. ದಯವಿಟ್ಟು ಈ ಒಂದು ಕನ್ವರ್ಷನ್ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. Joules to electron volts. If energy has to be converted from joules to electron volts, divide it with the charge of the electron, which is 1.6 into 10 power minus 19, 9.32 into 10 power 8 electron volt, or 932 into 10 power 6 electron volt. So very clearly, 1 atomic mass unit is 932 million electron volts. So yesterday we have shown 1 atomic mass unit is 1.66 into 10 power minus 27 kg. And from the theory of relativity, in terms of electron volt, 1 AMU is 932 MeV. Now we study a beautiful concept called mass defect, for which I will consider an example. I bring a cake of 1 kg to home. ಯಾವುದೋ ನಿಮ್ಗೆ ಏನು ಇಷ್ಟ ಇರುತ್ತೆ, ಪ್ಲಮ್ ಕೇಕಾ ಯಾವುದಾದ್ರೂ ಸರಿ, 1 kg cake. I cut the cake into small pieces, very small pieces. Reunion those pieces, measure the mass, it would be something which is 0.999 kgs. Andre, there is a small fraction of mass that is lost here. Similarly, I will consider carbon, whose actual mass is 12 mu. I assume carbon 12. But when I measure the sum of the mass of its constituent particles, protons and neutrons, it turns out to be 11.999 AMU. So very clearly you are observing there is a difference between the actual mass of the nucleus and the sum of the mass of its constituent particles. Actual mass of carbon is 12 mu. I will measure the sum of the mass of its protons and neutrons, the so-called nucleons. It turns out to be 11.999 AMU. So there is some difference in mass. So the difference between the sum of the mass of the constituent nucleons, the sum of the mass of its constituent nucleons and the actual mass of the nucleus is called mass defect. Actual mass of the nucleus minus the sum of the mass of the constituent particles is called as mass defect. But my physics has told in any system mass has to be conserved. Then where is that missing mass going? It cannot evaporate like that. Please to understand, students, that difference in mass, whatever missing mass is coming into picture, it is used for the formation of the nucleus. It is not wasted. It simply doesn't dump away. Then where is it present? It is present for the formation of the nucleus. And delta M, mass defect, is given by the expression delta equals ZMP minus A minus ZMN minus capital M. M, actual mass of the nucleus. MP, mass of each proton. Mn, mass of each neutron, which means the terms inside the bracket is the sum of the mass of the nucleons minus the actual mass is called mass defect. So what is mass defect, students? It is the difference in the actual mass of the nucleus with the mass of its constituent nucleons. Where is that missing mass going? Utilized for the formation of the nucleus. In mass defect ಅನ್ನೋ ಒಂದು ಪದ್ಧತಿಯಲ್ಲಿ ಯಾವ ಮಾಸ್ ಕಾಣೆ ಆಗಿರುತ್ತೆ ಅದನ್ನು ಕಳ್ಕೊಳ್ಳಲ್ಲ ಸಿಸ್ಟಮ್. ನ್ಯೂಕ್ಲಿಯಸ್ಸಿನ ಫಾರ್ಮೇಷನ್ಗೆ ಉಪಯೋಗಿಸಿಕೊಳ್ಳುತ್ತೆ. Now you study something called binding energy. Bind. It is the minimum energy required to bind the nucleons inside the nucleus. We are keeping the nucleons firm inside the nucleus. We are binding them inside the nucleus. We are not allowing them to go out of the nucleus because of the existence of some energy called binding energy. Or it is also the energy required to break open the nucleus to its constituent particles. If I want to break the nucleus, I remove the constituent particles. Some minimum energy has to be given, and that is called binding energy. Always remember, binding energy is the product of mass defect into C square. While doing calculations, very important to calculate binding energy, delta M into C square. Mass defect into C square. So this is delta M into C square is called binding energy. So in my today's class, we have understood about electron volt, Einstein's mass energy dependence, mass defect, and binding energy. The next session, I'll come out with a very important, interesting topic called binding energy curve. Until then, glance the session. Have a nice time. Thank you.